All right, so there's lots of possible answers for each of these. Let's just look at some sample answers in terms of drawing some sort of graph. So the first one, we want the point to be defined, but the limit does not exist at that point. So who knows, maybe I have some sort of graph that comes up to the point and it includes this point, so it's continuous from the left at that particular point, but then there's some sort of gap here and then it continues on the other side. So who knows, maybe there is an X and a Y axis in here. It's not necessary that we actually have it. And let's say that's the number 1. And we can see that this function is, say, continuous from the right side at 1, but it's not continuous from the left side of 1. All right, and I can also see that it's defined here because I have a point value at 1. It's colored in there. But the limit does not exist because you have differing left-right behaviors. We're going to 2 different numbers, whatever those numbers turn out to be. Okay, so now I have the reverse situation. Here, we want the limit to exist, but the point not to be defined. All right, so one thing I can do is just basically have this drawing that I have here, but have these 2 pieces joined together with like an open circle that's inside there. So who knows, maybe the same kind of X and Y axis. Maybe I come up to a point, not include it, and then continue it. That's right there. All right. And then just like I did before, who knows, maybe this is the number 1 or something like that. And the function's not defined at, let's say f of 1 is equal to, who knows, because there's no point there. But the limit still exists because we're approaching the same number from either side. Okay, on my third drawing, we want neither the function to exist nor the limit to exist at that particular point. Well, what if I took this same exact drawing that I've been drawing all along, this one, and I duplicate it? No, try that again. I duplicate it, bring this over here. How can I doctor this one so it fits this description? I only have to do one thing, and that is hollow out that point. Bam! All right, so now the function is not defined there because there's open circles on both of those things, and the limit doesn't exist because we have some differing left-right behavior. We have a jump discontinuity. Okay, that's not the only way you could have done it. You could have done maybe some sort of vertical asymptote at that point as well, right? To make it look like that Atari symbol or something like that. Maybe you had something that looks, it goes up to that and comes back down, something like that. You have some sort of vertical asymptote in there. That would be another possibility there. All right. So then, let's see then about this last one. We want the first 2 to work out okay, the point defined, the limit to exist. However, those 2 things don't join up. So this time, I'm going to doctor up the one that's right here, the second one. I'm going to doctor up this one. So I'm going to copy that one, duplicate it, bring that sucker over here. And then in order to make it so that the first 2 actually are satisfied, I need an actual point value for 1. So I'm going to color in a point someplace else. Who knows, maybe I put it actually on the x-axis right there. So now our point is defined. So f of 1 is equal to 0, golden. The limit exists because it hits this value. Who knows, maybe I make that 1 too from both sides. But those 2 things are not the same, and therefore I can conclude that the third one is violated, and none of these things are continuous at 1.